This segment is on belay lines or tinned lines. You have a couple different options for your primary configuration, and you can refer back to the belay sections of the video reference guides to review all of the options for that component. But your belay needs to have the capability of mining two-person loads if they possibly get loaded, if you have any vertical down points. If you're just doing a lateral or horizontal entry, you still need to use a standard belay system that requires manual control. You'll see some schools of thought that just involve one person holding or managing the line. And what we have found through training is that if the deployment of that line does not require actual manipulation, a lot of times that line gets neglected. And if the interior or entry team loses their communication system and has to revert back to a rope tug system, a lot of times that communication model will get missed because the line's not being managed. So whatever belay system you choose, make sure that it's one that requires minding. There's also some other schools of thought on how many of these systems you use. The basic premise is that every person on the entry team has to have an attachment point to a tinned line or a managing line. Sometimes that line, or all times, that line will double as a belay and tinned if you're doing a vertical entry. The method that we have found is the most productive is to use a single belay line or a single tinned line so that you don't have multiples going into the space that require management. In doing so, that requires some nuances for attachments. So when our first rescuer is ready to make entry, we're going to go ahead and take the end of the belay line and hard link that into the rescuer. All subsequent rescuers after that point will be on glide points on the same line. By glide points, we're referring to a piece of webbing or a prusik. That rescuer would do nothing more than clip a carabiner as that gliding element onto that line, and then take the other end of that system and hard link it into their system or connect it into their harness at their rigging point. Now that subsequent rescuer can move freely on that line regardless of the movement, stopping, or advancement of the lead rescuer. It enables you to bypass one another in the hole if you have to by disengaging temporarily and then re-engaging onto the line, and requires very little management on the space. It also makes life a lot easier on the guys on the outside of the space because now they're only tending one line instead of potentially four if you have an entry team and backup team in the space. There's a little change with this phase of the operation if you're doing a vertical entry. So if we have a lowering system built into a tripod and we're lowering our rescuers down into the space, the lead rescuer again would have the end of the rope with a knot hard attached to his rigging point on his harness as a standard belay. All subsequent rescuers, instead of using a glide point on that belay line, would actually take a prusik, attach a prusik to the belay line, and mind it as they are lowered into the space. That gives them an attachment point to the belay line if the lowering system fails, but does not require you to disengage that tending line and retrieve it to the top side, leaving your interior rescuer untended. So those are all the applications with our methodology with confined space as far as the tend line and the belay line.